is returning to its equilibrium, and R term ensures that it is utilizing the minimum controlling effort. Now, the derivation of finding solution of this optimal control problem is very long, and it's a part of calculus and variation course. But if you look at this linear quadratic regulator problem, couple of things to note that it allows you to choose these weighting matrices Q and R in order to find the solution. And the Q and R, you can choose it arbitrarily. You have an option to choose kind of weighting function which allows flexibility to choose, but it should have some kind of a physical sense. So when you are choosing a Q, it always remember that it is related to the state. The higher those values will be, you are forcing the states to come to the final steady state value as quickly as possible. At the same time, if you choose your R, you are assuming that the control force, the amount of control is larger value of that. So in practice, you need to have a balance of Q and R. If you look at the R is positively definite, which means the element you are choosing a diagonal matrix of R, the elements has to be positive. Q is semi-definite, so it can have positive or zero. Bottom line is don't choose, you are choosing Q and R to be a diagonal matrix, don't choose them, be negative value. Just give them Q and R has to be zero, has to be positive. So the solution, if you solve this problem, the control design problem with the selection of Q and R, it boils down to, it will give you a matrix Riccati equation where the idea is to find matrix S, which is a time-dependent matrix, and this S will give you the controller gain. This S is related to the R, B, with the control distribution. So optimal control problem, LQR problem, solve for this S, and from that you calculate your gain. This is the most optimal solution, which is a time-dependent controller gain, which is called the Kalman gain. In most of the engineering problem, we are interested to solve problem which has to be time independent. So physically what it means that we are interested to controlling the steady state response and controlling the system over a long period of time. So we can have a flexibility to solve an equivalent suboptimal problem, and we can choose this S matrix to be time independent, and that will lead to the solution of an algebraic Riccati equation. Solve this equation, it fits out S, and then we can calculate the control gain. This is a structure in MATLAB. You define your state space system, and it gives you the controller gain. Solve for S by solving the algebraic Riccati equation, and it also gives you the eigenvalue of the closed loop system. You input your system, you input your weighting, Q and R, and gives you the controller gains. So let's look at what's the effect of the Q and R. The other thing is the LQR control, it ensures the stability of the system. It will always give you stable system. So let's take a single degree of freedom system, and which has this open loop holes, and we want to have design optimal controller for this. I chose an undamped system, which means the system has keep on oscillating, with a constant frequency. So I want to design a controller, an LQR for such system, so that the oscillation dies down at the quickest time possible and with the minimum controller effort. So if I choose, I have shown you three different choices of the Q and R matrix. In the first one, I have the Q and R, I chose to be the same. In the second one, I chose Q to be 10 times more than R. I preferred more weightage on the state. And then In the third case, I chose R to be 10 times more than Q, so I give more weightage to the controlling element. All three cases, the marginally stable system or undamped system becomes stable. Motion will stop. Now let's look at the difference. So let's look at the R and Q. We have the same weight. The system dies down, and you have this is the controlling effort. If you take energy of U of t, this will give you how much power an actuator will need. If I take Q to be 10 and R to be I have more weightage. The states to go to its equilibrium, dies down. So it dies down, but it put more effort to control. So you gain a performance that your system goes to zero more quickly, but you lose it in terms of you're paying more energy and power to your actuator. The same thing if you choose R to be 10 and Q to be 1 or I, now your performance is not that good. The system is dying down, it is taking more time, but it has the least controlling effort. So these are the few tools I wanted to show you. You can do pole placement. I hope that you have a better understanding of a selection of actuator or sensor in terms of creating B matrix and C matrix. Physical space, you hope that you will be able to now do balance, internally balance induction, motor reduction, LQR control, and you know that you can decompose the system into modal coordinates and then solve the resulting system by all these tools. And these are the tools we use for large system. So what I want to do now, we have 1 hour, please. So I have a problem which I want you to solve together. How many computers here?
I have a last slide from the last question. This right-hand side signals U of t. It's a signal. He said it takes more energy. How mathematically you evaluate the energy of this signal? The area under the curve. Suppose. What mathematical technique or formulation you have to measure that how much energy is contained in 3 different signals?
How will you quantify it?
He said it's more energy. When you are presenting in such seminars, there may be someone who say, give me an interpretation, show me a number, which is in terms of energy, it's more.
Sir, if we break down in frequency, if we analyze in frequency domain and we find out what is the RMS of fundamental, so according to that we can tell that this is the more energy as compared to other.
It's much simpler.
Yes.
Just think about it. If any signal, if you have to quantify what is the area of that signal.
Or from here also we can directly find U transpose U, which is U square. Square of any signal is a direct indication.
Or MATLAB.
So that's what is the concept of norm. Q norm is a direct measurement of the energy content of any signal that you show in your graphical representation. So when you say that you have a signal and you calculate the Q norm of it, it depicts the power or the energy that is contained in the signal. From there you can also conclude that how much energy that you have in those signals. So sometimes there will be very few people who would like numbers rather than showing simply the graph. And you can, there are some advanced strategies. You can do norm minimization to minimize the amount of content. Because if you, suppose somebody says that this much energy I cannot spend. I don't have that much of energy coming from my source. You have to minimize. So what you will see many people in control talking of norm minimization. So minimizing a norm means you are trying to minimize some sort of. These are something interpretation of these graphs that are being shown later. Right? So norm is something very important calculation that we use in control. Right? At least two norms. Forget about infinity norms. We use in case of suprema, infima computation, higher bound of the signals. We try to take in frequency domain, all those tricks we use. Infinity norms mostly we use in frequency. But in time domain, it can be U transpose U. These are also very important for control people sometimes to answer some of the questions and relate. This is how I show a graph. This is what it means.
The other thing you should know about LQR, that LQR, once you choose Q and R, you don't have control in closed loop codes. So if you have to, let's suppose if I have to do 10% damping or 20% damping, I can't do it by LQR. If I have to do it, what I need to do? That's an inverse problem. You need to come up with a design of Q and R, which will give me the prescribed code. So LQR ensures that it is the least controlling effect, ensures the system stability, but for an arbitrary choice of Q and R, you cannot prescribe what your closed loop is. Okay, so I'm here for 1 hour. I can feel free to ask me any question. I have come up with one problem. It's not that big. In the meantime, I will try to put everything in the Google Drive, which Ajit has shared with me. Okay, I don't know if I can't print. Can I? Do we have access to Google Drive now? Everyone has an access? Let me try to put it in. Meantime, you can come and check it out. I'm trying to. What I have, I've given you 3 degree of system. Okay. Yeah, but they can't read the complete thing. That's what.
Part by part.
And I want you to first design the full state feedback control. I want that the closed loop system, you have damping 10 times more than the open loop system. You can also compare what happens if I choose different type of single input and multi input. Look at their norms, like Dr. Day said, look at the norm of the BUC and see which one is better. Then you can design an observer. Once you construct your A, B, and C matrix, you can then come up with observer design, LQR design. The thing is that I need to put this slide in the Google Drive. Then you can look at some of the commands I talked about. Yes. But why don't you start constructing the state matrix first, constructing the B matrix, and then use the place command for the control gain computation. Tell me, how are you calculating the damping? Do you know how to calculate damping from the poles? I don't know if I told you. Do you know how you calculate damping from the poles? Just listen to me. When you calculate the poles, I of A, let's suppose, it will give you, no, these are the poles. It will spit out the complex pole. Each pole is minus zeta omega n plus j omega n 1 minus zeta square. Yes? In MATLAB, there is a command called damp. I will open my computer and show you. Dam of this vector S, let's call it S, will spit out the natural frequency and damping ratio for it. It basically solves for each pole, calculates with zeta and omega. Once you know zeta and omega and for open loop system, then you can multiply the damping 10 times and design your pole. I just want to get a feel what are you designing your closed loop poles to be. I muted Raju for a moment. I need to put these on the.
You don't want recording?
No, I want recording, but at the same time,
You can do it. Finish it.
I was going to my email and things like that. For a moment, I want to mute it.
Muting has to be done across your computer.
Just give me 1 minute, guys. No, can you write down this matrix first before I go offline for a minute? Just write down the matrix. If you are smart, come here and take a picture. Everybody has a phone. Come. Then at least you will have it here. Just the first portion of the problem. In the meantime, I will upload all the documents in the Google Drive. Start working on this side of problem and let me put everything in the Google so that you will have access.
See if it is shared.
Yeah, that's what I
Your examination will have two components. 50 marks will be theory, 1 hour, and 50 marks will be this laboratory based. Some design problem will be given and you will have to solve. So lab can be done in a batch of 2 or 3. So that will be 100 marks exam, 50 theory and 50. So lab can be done always in a group of 2 or 3. That will be assessment. And finally going to the grading as per our institute norms. Grade sheet will be.
will start working as a group and
So it is
talk
better
to-
you formulate a group
Group,
now.
yeah.
So when you appear for exam, that group sit down. And are you going to make your test open or closed book? Open book. So your 50 marks theory will be open book. Open book exam. You can bring books, material, whatever. Laptop, Google, everything is possible.
1 hour exam. You just have to realize, do your best. ये पानी से कपड़ा लेकर don't have slides. Yeah, just I'm uploading. Just you will find it. I know. Without that, it will be. I don't want you to work out by hand. Really, just you don't calculate inverse or difference. Use MATLAB. Just try to write it in MATLAB. Why don't you define mass, thickness, damping matrices in MATLAB and try to write in a spreadsheet? And I will just put it there. Lecture 2 slide is uploaded. Can you see it? All of them are. Yeah, refresh your Google Drive. You should have all the lectures now. So for open loop system, first create the matrix A. Okay. You have M, C, and K. Look at your slide and see how to construct A.
A B करें, मतलब C D करें, इसके बाद अगर स्पीड बढ़ता है, ना, give them commands and say use it, and you will support it. Once they get acquainted, next class you will see that it gets applied. वो फोल्डर व्यू के किया जा सकता है. I have given permission. You can edit. You can also. I will share all the pictures also.
You see the control code, these are the network on the slide. That's what you here is the excitation. You don't have to worry about it. You have to simulate the control system. Then you use it. That's what I was asking you. How you select here? You have or select the scene. If you have sensor at the location. You have half the problem to take a picture. Full problem? So what? What's the question? Full state feedback, you have sensor at all the states. You have all the states available. This is in the physical space. Yes? So look at the slide. This is just an open loop system. You just need this matrix A to calculate eigenvalue. If you want to simulate it open response, then you need just B of L. Yes? You just need to construct this A. Did you hear me what I said? No? Okay. You have this given to you to construct this matrix A. That's your statement. That's the first thing you do. Calculate its eigenvalue. Okay? And from the eigenvalue, you can calculate the damping ratio and natural frequency.
It's the same way you choose the state variable.
Yeah.
In controllable canonical form that you get AP. Q is one state variable, Q dot is one state variable. Then you have Q double dot. This is the last one that comes out. Right? That's the exactly similar equation. Use your state variable from a differential equation and get CCF format. It's exactly the way you get M inverse of something.
Yeah.
Who got the job? Who got the job?
Hey, if you have these, this is the physical system. Your mass matrix, these degrees of freedom. So when you are creating your state variable will have x1, 2, 3, but let's not call it x1. Three physical degrees of freedom, you will have 6 state variables. This is your state variable. Six state variable x1, x2, x3, x1 dot, x2 dot, x2.
Basically augmentation.
What are you doing here? So right, you define MC and K matrix. Show me that slide. Yeah. Then you construct this K matrix. No, this is good. Construct this K matrix. You have M, have K. This is 3 by 1. This is 3 by 3. This is 3 by 3. So you construct this matrix. Yeah. You can directly do it. What are we doing, guys? This is not A. No, that's fine. But you don't have to take eigen value of the mass. You have that slide on your phone. Slides. 1%. I don't. 1%. Construct this way. This way. Okay? Because you have defined M, A, and C, you can construct. This is the matrix of 0. This is the identity matrix. Construct that matrix. The eigenvalue of that matrix is the poles of the open loop. Okay? Okay, so I have university. That slash and that 0, 1 are matrices. So let me write. So it will be. Let's, okay. May I have attention? Some of you have this question. Look at this matrix. You can input. You can create these three matrices in MATLAB. Yes. Now, in state space, what's the dimension of the state? How much? What is the dimension of this? 3 by 1 and 3 by 1, yes? So 6 by 1. So the A matrix has a size 6 by 6. The first 3 by 3 are 0. This is a matrix. Next 3 by 3 is the identity matrix of a size 3 by 3. So it's 1, 0, 0. Here it is inverse MK. Then this is again a 3 by 3 matrix. This will give you 6 by 6 matrix. You can create all the zeros of that dimension. The MATLAB command is zeros. For example, if I choose n to be 3, this will give you a matrix of zeros. And this gives you the identity matrix. I have given you the command how to create zeros. You can create a matrix of zeros of 3 by 3. Like that.
Please do it in M5, don't do it from command prompt.
Yeah, always do it in M5.
Don't know. Command prompt is Vector A is 6 cross 6. Vector is 3 cross 2. 2 n cross 2 n.
Just do I of A, that is your open loop eigenvalue. And then there is a command called damp.
We don't use damp here in the latest Session-2 version. This is a new command.
So it gives you natural frequency and damping ratio from any complex function code. Yeah, calculate the poles first. You will check the post. I will tell you what the post. Show me the image. Number I can't. Just show me the code. Show me the code. I can't. Yeah, I know. So just now you calculate the eigenvalue with that.
How many of you are not comfortable with controllable canonical decomposition from a second order differential? You have done it for scalar case. Yes, sir. Now it's a vector. It's a block partition matrix that you are getting now. It's a 3 cross 3 block that you are getting in a A. I find some of you have a trouble in getting into CCF. Actually, the concept of CCF is so for mainly for undergraduates. We have gone through this process, I believe.
You can verify that you are constructing a matrix correctly or not. So let's suppose I call P to be the eigenvalue. You will get this complex conjugate 6, and there is a command. This will tell you what are the frequencies. You know, naturally it's 3 degree of freedom system, so there is only 3 frequencies and 3 damping ratios. So those frequency and damping ratios are given to you.
Found out what is coming out to be different than this value.
Is it different? Let's look at what is my M.
In my case, is the same.
Are we good? Like, is the number?
Matching with me.
Let's see. Just check your M, C, and K. What is your M? That will be the only. Got the same poles? Yeah. Then what's the problem? You have the same eigenvalue. Yeah. So that's good. Okay. Now, আমি বাংলা বুঝতে পারি না। As everyone has the same A? Yes. Now you have to construct your closed loop poles. Yes. So can you create a loop where you multiply this? The new damping ratio will be how many times I told you? So that there are only 3. Now you just create. What is the formula for creating a pole? Yes. So once you define your new damping, your omega is the same. You can construct your new poles with this new damping ratio. Construct 6 of those first. Then we will use the place command based on the choice of your controller. Huh? Come again? What did I say? You have this damping from your open loop ports. Yes? In our problem, what I want the closed loop system to have 10 times more the damping. So I can construct this damping ratio now. These are the new damping ratios. I have omega and this new damping ratio. From that, for each omega and each damping ratio, I can construct this. Those are your new ports. New. I am not asking you to just do -1 plus 10i. It does not mean anything. But this will tell you this is how much damping I want, 50% or 10 times more damping than the previous system.
It's not a very easy problem. If I have a pole which looks like this, and immediately I tell you in exam, tell me how much is the damping and how much is the natural frequency from an imaginary pole, complex conjugate pole. It's not a very easy algorithm.
Yes,
to separate out zeta and omega 1, that's what he is telling, the command damp, which has the ability to segregate zeta and omega n, which you may not have studied earlier. So given a complex number, which you are calling it as a pole, you are segregating zeta and omega n. Most of the time, we really face a problem that the desired pole location are complex number given, but we don't know how much is the component of zeta and how much is the component of omega.
This gives you a quantification of damping. Sometimes we can ask you how much damping you have introduced.
Until you do some trigonometric algorithm and measure theta in a graph, you can do that. But using that, you can find it.
Now do help command. Help. Once you construct your new mu,
I think you can trigonometrically you can do this. Once you know this, you have to write few line of codes and you can find damping ratio, right? But damp is helping you to solve it very easily. Yeah. So there may be numerical some changes in the value. If you write few lines of code and find it, and directly you find maybe this will be more accurate.
3 by 3, it's a 6. Just construct by right. If you have a problem, write the new damp 10 times the old one plus omega plus square root -1. You can create the first pole, copy, repeat it for other poles. I want you to construct 6 closed loop poles.
Segregating theta and omega and by simple command, and if not do anything trigonometry. Yeah.
Second one will be the complex one will be considered. Third one, make it necessary. This is somebody was asking. This creates those zeros for you. This creates the identity matrix. There is a command for inverse. What was the other question?
You can switch on
Your are you getting the same polls? Check it. Conjugate is CO and J. Conjugate. So this open loop is the damping. That gives you only frequency.
It has to declare on the left hand side both, then it will extract.
Otherwise, by default, it will just give you. That's what they're defining. This is they're designing close to No, K, no, K. This is not. This should be a closed loop port to design correct.
It's a 6x6 matrix. 6 item value will come. 112. See, one interesting thing here is a deviation from what you have learned. It's a sixth order system represented as a second order differential.
It's a 3-second order differential equation, so maximum will be.
So any large scale system and usually robotic system are usually modeled in this. They normally go for second order, because if I ask you give us 6 differential equation and 6 equation and say do the analysis, you will say that it's a higher order system. Sir, पोल कैसा निकालेगा हमको तो कुछ मालूम नहीं है. You are using the concept of second order for a 6 order system and solving it actually. So that's an interesting fact that you may not have used it, but in most of the mechanical system you try to do it that way, because for them is position, velocity and maximum.
Do you guys get this? Oh, yeah. Now those who have completed it, those who have this new pole, do help place commands. Help place. The place will show you what are the structure for or syntax for finding a control. You need to define a B matrix first, and then you can do it. Yeah.
For each state of zeta, we get 2 values of 1 to 4.
But no, that there is only 3 unique omega and 3 unique zeta.
But there is for each zeta value there is a plus minus combination.
No, I mean this is just a pair of S12. That's the reason you got. No, this is S12 together. The first pole, first pair of pole are the complex conjugate.
Yes, yes.
Both will give you omega and zeta to the same value.
Yes.
Yeah. Yes, 1, 3, 5, and then complex conjugate. That's why when you're solving for damp command, you will have omegas repeating. First, second repeating, third, fourth repeating. Physically, it's only 3 degree of freedom system, so it should have 3 unique natural frequency, 3 unique damping. That's all I want.
Q dot.
That's usually a deviation in mechanical system.
Any other question from the back? You guys are we good? Do you want me to come and help you?
In our control theory, we could have gone up to x5 and all the x4 dot, x3 dot, x4 dot would not have any meaning. But here, q 3 displacement, q dot 3 velocities. Mostly they will try to do it this way only. The modeling will always be mq dot c of q, q dot plus k of q equal to some. All manipulated systems will be modeled exactly in the same way. This is the nomenclature. Maybe it's a structural problem, aerospace problem, and robotic problem. This will be the nomenclature. Because in robotics, you don't go above position, velocity, and acceleration. So there is no question of any hypothetical variable selection. If you see A matrix, if the first row, the first block you want to see, it is 0 and I only. Na? Where are you getting the eigenvalue? The bottom one only. M inverse of C and M inverse of K. That will supply you the eigenvalues. That is 3n cross 3n. 3 cross 3. That will give you the eigenvalue. The upper one is not going to give you. Because that's a 0 block and one is added.
Yes, this is the physical one. The state space, what will that become? 6 by 6.
Zero M inverse B of C. Okay, sir.
If this is B of C and then this is U of C, then this is your B matrix. Zero
M inverse
M inverse
B
value.
of B.
The column of that is zero will be the same as column of this. This is I have given B of C.
So that for them, still it says this. ABCD. Check probability. Check observability.
Do all of you have this new pole, mu1, mu2, mu3, mu4, mu5, and mu6?
Actually, single.
Now use base command. Instruct how will you check it? That the control gains are correct. So A minus eigenvalue of A minus B times B is due to the force.
But actually, so we are responsible complex value.
You may have a variety in
But because of that, everything is changing like from here to this. But these are
So now you try with different beats. You have given that the slide the controller will change. Take the cards. Once you constructed, what's the same? If it's a decimal point error, then don't worry.
But after that, then three values should not change.
You've got K matrix. Mine needs 2 norm. It will be positive now. That is the quantification. This much amount of amplification of signal that you are passing to an equipment. Now, say U is some force that's multiplied by something 5 times something. Now, if you are finding that your actuator is not working with this gain, then proportionally you will have to reduce that value. So, individual component you don't know how they are being computed. So if you have to get an idea through norm only, you can get that I have to minimize this value. Then all the individual component of K will also eventually get reduced. So there comes the method people nowadays use called optimization. Right? And using some technique of optimization, they try to tune K. Because this is fixed K you are. That K passes through a motor. Motor gets saturated and that will not give you any effect, right? Or the things get burned, right? So in that case, you may be required that 5 point something is not working because you are propagating U with K, U with X. K of X is U, full state feedback. So you have X coming, state variables getting multiplied with K and then going as a control coming. So now 5 point something unit that you have calculated, when it's got multiplied with X signal, propagated, you are finding that U that is going, say, exceeding some 230 volts, some force or whatever. So in that case, you may have a problem in industry that somehow K needs to be reduced. But you know if K gets reduced, your performance cannot be attained. Keeping performance still, you require less K. This is again a type of problem which is people do something called optimization, constraint optimization. You have a constraint that K should be minimum, still performance will be. So you cannot get exact performance, you will do some trade-off. Though these designs are very good, but they have limitations when they are directly.
Yes, sir. It is for what is the state of suppose survive and get only one value. We need to also change.
You don't.
We cannot change it.
Yeah, you cannot change. And that K may not be feasible practically.
To make it feasible, the performance will go down.
Performance will go down. So then people use some sort of constraints, some bounds, and within that they will try to keep K. So there are some many more variants of full state feedback control where you have some extra degree of freedom. You can change the value of K. Because you will find sometime a very successful design of full state feedback control. Some of the element of K is coming in 10 to the power 4. But 10 to the power 4, and if you try to find a norm, you can just imagine what will be the value of K units that will come. That cannot be at all feasible to be applied to expert. That's exactly what my problem. I designed a key, full state filter. My guide saw it. No more multiplication. Now you use case. Then we need something for
A and B. Now you have defined most of you A, B. You have to plot the response C or output feedback will be defined C. All the codes for the modal balance I have given you, the commands, LQR, you can directly use it. You try it, and I can easily send you the code, but I want you guys to try it. Once you struggle it, you understand the process more. Okay? Eventually, I will give you the code. Don't worry about that.
So tomorrow morning 9 a.m. Please come at 9 a.m. Ravi, you will get a call. Maybe he will get a, yeah.